The South Container Terminal of Colombo Port comprises three 100,000-ton container berths with length of 1,200 meters. The top elevation of berth is 3.0 meters. The design bottom level of the harbor basin and tombing circle is -18.0 meters, LWOST. The harbor is constructed to be able of berthing 18,000 DWT vessel to 175,000 DWT post Panamax vessel, even up to maximum of 18,000 TEU container vessel. The container terminal rail spacing of quay crane is 30 meters. The stacking yard is around 58 hectares. The capacity of the South Container Terminal designed to be 2,400,000 TEU per year. The cutter suction dredger with capacity of 3,500 cubic meters per hour is adopted for the harbor basin and tombing circle dredging. The terminal land area is reclaimed by the suitable dredged material. Temporary construction yard is established on the east side of the South Container Terminal after the land area is reclaimed, and then the temporary site office, living quarters, caisson precasting yard will be constructed. Rock material is transported by 30 to 50 cubic meter hopper and placed over the excavated footprint. The riprap work is carried out layer by layer, and the compaction work is carried out by using 5-ton ramming boat. Footprint leveling is carried out by the driver, using the scraping rod with rock material supplied by the string device, and a 200-ton barge is allocated to support the operation. The precasting work of caisson is executed layer by layer. The bottom shuttering consists of structural steel, timber deck, and fiberboard. Reinforcement bars will be fabricated over the bottom shuttering. Further, the props will be used for reinforcement work. Put the vertical steel bar for cross bulkhead, then the horizontal reinforcement. Both the outer shuttering and inner shuttering are steel structure combination formwork. Gantry crane is allocated for installation and removal of formwork. Meanwhile, the concrete mixer and pump truck are used to support the concrete work. Both the land transport and water transport are used for caisson transportation. First caisson is transversely shifted to the vertical way and longitudinally shifts to 4,200-ton semi-submersible barge by using gas bag. Second, the suitable tugboat is allocated to drag the caisson to submergence location, then to installation location, after semi-submersible barge submerge and filling water to caisson up to buoyant stability condition. With a 2,000-ton barge as the locating barge, 2 hoists and 4 chain blocks are allocated to support the first caisson installation. Installation of second caisson is carried out by virtue of the first completed caisson. With the supporting of 2 hoists and 4 chain blocks, the rest of the caissons shall be done in the same manner. This 100 kilowatt vibro flotation machine is used for ground treatment. The locations of the vibro floats arrangement will be like the vertices of equilateral triangle of 3,500 cubic meters per side. The formwork of the breast wall is made of steel, which is assembled by crane. The reinforcement work shall be carried out on site, and the breast wall shall be poured by 2 layers in situ concrete. The key surface concrete shall be poured line by line of each section. The track beam is 60-meter length for each section, which is poured in situ after erection of reinforcement. The barge is used to dump the rock for the underlayer, whose level is below -2.0 meters. The rest part, which is over -2.0 meters, will be carried out from the land. After the completion of ground treatments, the construction sequence of horizontal direction shall be from the west to the east and from the south to the north. The construction sequence of vertical direction shall be fire control and water supply work, communication and power supply work, stackyard work, road work. Section A, 516 days from commencement date. Section B, 547 days from commencement date. Section C, 730 days from commencement date. Section D, 730 days from commencement date. Section E, 778 days from commencement date. Section F, 848 days from commencement date.